Hey everybody, here is going to be our lesson for part 2, or I guess day 2, of our simplifying radicals notes and the last part of rationalizing our denominators. I'm going to do a review. So we've already done number 9. I'm just going to do it again with you. And then you can try the other 4 and then check how you did. And we'll do the same process for the next page as well. Before I do that, I'm going to write our perfect squares right here so we don't have to keep going back and forth. So 1 squared is 1. I'm not going to write that one down. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36. 49. 64. 81. 100. 121. 144. 169. 196. And 225. So that gives us 1 through, really 2 through 15 squared. Remember, the first thing we're going to do is look at our square root and ask ourselves, is this a perfect square? If it is small enough to be within our list of perfect squares, we can just see if it is. See, there's not a 162. It would fall right in here. If it was bigger than our list, like number 11, we're literally just going to check and see if it is a perfect square on its own. The way you would do that is just type in the square root and then whatever number you're trying to find. Let's say you had 400, you would just type in 400, and I'll tell you. Ours right here, the 162, is not a perfect square. It is somewhere in here. So we're looking at the squares that are less than 162. But my goal is to simplify by dividing by another perfect square. So I want a perfect square times something. I'm going to go back to my calculator. I might not know this off the top of my head. And I'm going to look at what's half of 162. The reason I'm doing that is because it couldn't be any bigger. Sorry, there we go. Couldn't be any bigger than half of 162 because it has to be something times 2 is the biggest it could be, or something times 3, times 4, etc. So I want to see what half of 162 is. That is 81, and that actually happens to be a perfect square right there. So 81 times 2. And then the square root of 81 is 9. So instead of writing the square root of 81, I would just write 9 times the square root of 2. And that was our answer. Remember, you're always going to make sure that everything inside your root symbol is fully simplified, meaning it could not be divided by another perfect square. And there we go. So go ahead and pause, do 11 through 14, and then come on back when you're ready to check it. Here are your answers if you want to check them. 11 and 13 were perfect squares, meaning that an exact whole number times itself makes the radicand in here. Same for this one, 5 times 5 is 25. Remember, the ones where we don't have a perfect square, that means we didn't have any single number times itself to make our value. An easy example would be right here. We have 96. 10 times 10 is 100, and 9 times 9 is 81. So it'd be somewhere between 9 and 10, closer to 10. But since it's not an exact number, that's why we're simplifying. So for number 12, we could do 16 times 6, and the square root of 16 is 4. And then for number 14, it was 108. That is also not a perfect square, but it is 36 times 3, and the square root of 36 is 6. And there we go. Perfect. So go to the next page. Now we're just going to do even more of that, practicing what we just did on this next page by also adding on a fraction. Remember, our goal here is to get an answer that's a rational number, meaning it does not have a radical symbol in the denominator at all. All of our answers, when fully simplified, will only have one radical symbol, and if it does have one, it'll be on the top like this. I'm going to go ahead and do 11 with you slowly, and then you can try the other ones. I'm going to write our perfect squares up here at the top one more time. Oh, I forgot 8 squared there. You saw me forget 8 squared. 169. Okay, there we go. I'm just going to start with number 11. Remember, my end goal here again is to get rid of the radical in the denominator. And to do that, I'm going to multiply by an equivalency of 1. That means I'm multiplying by a value of 1. It just doesn't look like 1, right? Square root of 50 divided by the square root of 50 is 1, because the same thing happens on the top and the bottom of the fraction. They would cancel out to make 1. But what I'm going to do here is be able to get rid of that radical in the bottom. So this is going to get me square root of 63 times the square root of 50 on the top. On the bottom, I have the square root of 50 squared. Remember, those cancel out to just give me 50. Now, I want to see if I can simplify anything over here. I don't have a number on the outside of a radical at the top, so there's nothing I could cancel out there. Remember, I cannot cancel from inside to outside of the radical. This is not 50, it's the square root of 50, which is some value between 7 and 8 with a bunch of decimal points. It is not a number, like a whole number. What I'm going to do here, just like we did on the ones that are up here at the top, we're going to simplify out a perfect square from all of our radicals to see if we can simplify the entire answer. I have 63. 63 is not a perfect square. It's very close to 8 squared. So I'm just going to see if any of these perfect squares will divide into 63 by using my calculator, and I find that it's going to be 9 times 7. And then I'll do the same thing for 50, square root of 50. Square root of 50 is not a perfect square. It's very close to 7 squared. So I'm just going to divide 50 by all of my perfect squares that are less than 50 and see which of those divides in, and that would be 25 times 2. And there we go. Now what I'm going to do is keep on simplifying. The square root of 9 is 3. Square root of 7 is not a whole number, so it stays like that. Square root of 25 is 5. Square root of 2 is not a whole number, so it stays like that. And then we have our 50 on the bottom. Now we can simplify on the outside. Remember, we can't simplify here or here because inside to outside doesn't work because this is not 2, this is the square root of 2. But I can simplify the outsides. So like this is 5 and this is 50. Both can be divided by 5. If I did 5 by 5, I'd have 1 left on top, and 50 divided by 5 is 10 left on the bottom. And I'll just check if I could simplify this 3 and this 10. You can't. 3 doesn't go into 10, and 3 is a prime number, so nothing else can go into 3. So on the top here, I have 3 times 1 on the outside. And then on the inside, I have 7 times 2. That's 14. On the bottom, I have a 10. Now, normally this will be our answer. We always just want to double check, though, if there's anything we can do on the inside one more time, because now that we've put these numbers back together, there might be different factors of that total number that could be simplified farther. But we have a square root of 14. There are no perfect squares that divide evenly into 14. The only two that are small enough are 4 and 9, and neither of those go into 14, so this is our answer. And there we go. Perfect. We'll do the same thing for number 12. So I'm going to let you try number 12. Before you pause, let's talk about this real quick. Remember, when I'm multiplying to get rid of the radical, I just want to get rid of the radical in the bottom. So I multiply this by square root of 12. I am not going to multiply by 6 as well. 6 is not in the radical. It is already a rational number, so it just stays there. Okay, go ahead and pause, see how far you can get, and then come back when you're ready. Is number 12. I did try to color code. Hopefully that will help a little bit if you're confused by how many radicals we have. So I've color coded all the 1/28ths and what it breaks into pink, and then everything from square root of 12 into red. And you can see here our 6 stayed in the bottom because it didn't have a radical. It did end up multiplying by the 12 we have here. 6 times 12 is 72. And then from here, I just simplified the radicals at the top because there's nothing out here to simplify with my 72. So 1/28, not a perfect square, but it is 64 times 2. Same thing for 12 here, not a perfect square, but it is 4 times 3. Now I'm just going to simplify my perfect squares. Square root of 64 is 8. Square root of 4 is 2. And then square root of 2 and square root of 3 are not whole numbers, so they got brought down. And then we just simplified from top and bottom on the outside of the radical. I had 8 out here and a 72 out here. 8 goes into 8 one time. And then if I divide 72 by 8, I get 9. And I did not simplify anymore because there was no number that divides out of 2 and 9. And then I just re-multiplied what was on the inside to give me that 6. Remember, I cannot simplify from here and here because this is on the inside of the radical and this is on the outside of the radical. And that's the answer. Perfect. Okay, and our last two are 13 and 14. Go ahead and pause and try them and then come back when you're ready. Go ahead and check number 13 and number 14. I'm going to go to 13 first. Here is the whole thing. We had a square root of 12 on the bottom, so we multiplied everything by the equivalency of 1, square root of 12 over square root of 12. That got us to here. There was nothing on the outside to simplify, so I just went straight into simplifying my square roots. I've color-coded here. 27 is 9 times 3, and 12 is 4 times 3. Square root of 9 is 3. Square root of 4 is 2. And then from here, I just simplify what was on the outside. I had a 3 and a 12. 3 divided by 3 is 1. 12 divided by 3 is 4. And then I simplified again. I had a 2 on the outside and a 4. 2 goes into 2 one time, and it goes into 4 twice. If you wanted to split that up into 2 steps, you're welcome to do that. That leaves us with 1 times square root of 3 times square root of 3 on the top. Square root of 3 times square root of 3. 3 times 3 is 9. And then we just had a 2 left on the bottom. And the square root of 9 is 3. And that gets me to here. And then our very last one here, I didn't color code this one because it was a little bit different. We multiplied by the square root of 6, top and bottom, equivalency of 1. That got us to here. And then if you try to split up 15 and 6, neither of them could be divided by a perfect square, so there'd be no point in trying to separate them. If we split this up into like that, right, you see how none of them simplify into a perfect square, so there's no point. So what we did instead was just multiply them back together to see if maybe we could simplify that one. That got us to here. And then I said, oh, well, wait, hold on. 90 is not a perfect square, but it can be divided by 9, which is a perfect square. It's 9 times 10. And the square root of 9 is 3. So that gets me 3 times square root of 10 over 18. And then I could simplify the outside. 3 goes into 3 one time, and it goes into 18 6 times. And that gets me to here. So biggest takeaway, always multiply by the same thing on the top and the bottom. Second takeaway, if you're not sure if it's your answer, like here, just always double check either is it a perfect square or could it be divided by a perfect square? And there you go. Hope it's helped. Bye.